Our next speaker is Professor Robert Engle, Nobel Laureate in Economics and Co-Director of the Volatility and Risk Institute at NYU Stern. We are honored that Professor Engle has recently joined the ADIA Lab Advisory Board, and it's a great pleasure to work on it's a great pleasure to have him on this symposium for the first time. Professor Engle's groundbreaking work on volatility and financial risk has reshaped how we understand uncertainty in markets. His statistical models have become essential tools of modern arbitrage, pricing theory, and practice. And today, he brings that expertise to climate and to all of us. In his keynote this morning, Climate Risk and AI, we will all learn more about how climate-related risks impact asset prices, government policy, and long-term investment strategies. Please welcome to the stage Professor Robert Engle.
Good morning. It's terrific to be here. This is actually only my second time in Abu Dhabi, but one of the things that's happening here is that our institute is establishing a branch at New York University in Abu Dhabi, and we're going to announce this formally on Wednesday. So my connection with Abu Dhabi becomes stronger, and my connection with ADIA Lab has become stronger. I'd like to talk today about what I call climate risk. And from this brilliant presentation that we just saw, we can see that there are enormous kinds of risks in these physics models. What we don't see in the presentation, but obviously is in the science of it, is the forcing variables that are part of this process, one of which is CO2 emissions. And I'm really going to talk about the economics and the finance of where these CO2 emissions come from and what we think the long-run future of those forcing variables is going to be, and I'm sure we can plug that into your physics models and learn the difference in climate that would be resulting from that. So I'm going to talk about risk. In finance, we think of risk as being a bad event that has some probability of happening. It has a severity, it has a probability, and what we're particularly interested in is, given the severity and probability, what is the loss that occurs if this event actually happens? If these events are far in the future, and certainly in these climate models, the future looks extremely far from in time. This is not, these risks in climate are indeed long-term risks. So can AI model these kinds of risks? Well, I'm not an AI expert, but basically, if there are repeated examples where this risk is either occurring or not, the loss is either occurring or not, we can treat this as a machine learning problem and actually do a very good job of figuring out the probabilities and the severity and the losses that are associated with these kinds of risks. But I think the climate problem is more like a stress testing problem where you're trying to ask a counterfactual. What happens if something in the future happens that we didn't expect and that was not in the past? Can we really do counterfactuals? We can't do them in the same simple way. So how can we do this? And I think the answer is mostly we have to do something which is a little more structural and but there still is probably a role for AI in doing that, and I'll talk about that in a few minutes. So most of the time when we do a stress test for a company, for a country, for a planet, I suppose, you would do the stress test with some scenario which you think is extreme but plausible. And the idea of extreme but plausible means that it's something that could happen, might not have happened very often in the past, and therefore is not amenable to this kind of machine learning technology that I just described a minute ago. So, as you all know, we've seen lots of events happening all the time which we associate with climate change. But mostly, what we worry about is that the future events are going to be considerably more severe than the ones that we've seen so far. The question of exposure to these events is a question that, what are the losses that we expect if these events actually do occur? The NGFS is an organization of central banks that has been studying how can you measure the stability of the banking sector when faced with these kinds of climate risks. They have used scenarios which they say are extreme but plausible, but they're based on sort of theoretically what you think might happen, particularly if we're on a schedule that gets us to net zero by 2050 as discussed in the Paris Agreement. Today I'm going to show you a different approach to measuring the stress of banks and other financial assets, which uses market prices and market expectations. And the question is, does the market accurately forecast these things? The answer is no. But the fact that market prices are responding to future climate risks is very important, because if these future risks change, market prices are going to change today. And market prices are what drive all the financial response that we are hoping will happen to mitigate the rate of climate change. So what are the risks we're talking about? Well, you might say that I'm talking primarily about floods, storms, droughts, and so forth that we saw on this map. But actually, it's not the main thing I'm thinking about. The main thing I'm thinking about is, what are the risks associated with our desire to stop climate change? If we are going to control the amount of CO2 and other greenhouse gases that we emit, we have to have public policies that do something about this. We have to change the incentives for emissions. Economics calls this an externality. We know that this is a market failure, and the primary solutions to a market failure are government policies. What sort of government policies? Well, carbon taxes, green subsidies, regulations. And I've put a fourth one down here. I call it hope. You might not think of this as a government policy. In fact, it's commonly called the do-nothing policy. But really, what I think hope means is we hope that all the citizens will choose voluntarily to do something which is more climate-friendly than what they've been doing. Economists are pretty pessimistic that that will actually be enough to stop greenhouse gas emissions. For some things, it's very expensive, but it's a part of most government policies is to hope that the private sector will do something. And so we're going to have to talk about that. Okay, so for each of these particular transition risks that we're interested in, there are winners and losers in the public sector. And this is one of the reasons why it's very hard to put these policies into place. We can think about a portfolio way of measuring this risk. That is, we can construct hedge portfolios which have the property that if the risk goes up, the portfolio is going to go up, and if the risk goes down, the portfolio will go down. What do? You divide your assets into those which are positively related to the risk and those which are negatively related to the risk, and form a long-short portfolio. Take an example. Suppose we're worried about a carbon tax, and when you say worried about it, think about you have a company, or you're investing in a portfolio. What are the companies that are going to be most exposed to this carbon tax? They're the ones with the most emissions. The most emissions are going to have to pay the most for when the carbon tax is in place. Some companies might actually do very well when there's a carbon tax because their competitors will be taxed. They won't if they don't have emissions. And they might even have a business model which profits from renewable energy, in which case a long-short portfolio between the high emissions stocks and the low emission stocks would appreciate whenever there is a discussion, even a discussion of putting into place a carbon tax. And this is how we get long-run risk measured today, that the assets that are in this hedge portfolio are sensitive to what they think the future is going to look like. And those assets will go up and down depending on what happens, what the discussion is, what they think the probability of an event occurring in the future really is. So this is kind of the technique we're going to look at. We have a hedge portfolio for each of these transition risks that we're worried about, and we want to see how these transition risks change over time and how they impact other assets that we might hold in our portfolio. I'm going to give these assets names, which you're familiar with, but maybe haven't defined in exactly this way. Brown assets are the assets which are negatively impacted by transition risk. So if there is a decarbonization policy, these assets will be hurt the most. If there are, we'll call green assets, those that see this risk as an opportunity. And these are the companies that are building renewable energy. They're companies that are going to survive and thrive in a world which has less carbon emissions. So this is a portfolio that you might invest in if you wanted to reduce the risk of this transition. But you also might be interested in portfolios which are correlated with this, because they would have similar performance. So what we're going to do is regress the returns on some asset that we're interested in on these hedge portfolios and other standard risk assets, and ask what the beta is on the hedge portfolios. If the beta is positive, we say this looks like a green asset. If the beta is negative, we say it looks like a brown asset. So it's a way of classifying all sorts of assets by their direction of exposure to this climate risk. So the size of the beta measures the exposure and the severity of the event. And if you know how severe the event is going to be, or if you have an idea, it can tell you actually what the dollar losses are going to be for this particular asset. And if the beta happens to be 0, you would say this asset is not exposed to this climate risk. So I'm going to show you some results. Here's actually, I was in Bolzano last week, and this is a picture which I took about 40 years ago, I think, something like that, of hiking in the Dolomites. This is a camera with film and stuff like that in it, old-fashioned camera. And this is risk. There's a fixed cable you can hold on to, but there is risk there. And so we're talking about how do we manage risk? And once we've defined it, we're going to have to ask, how do we measure it? How do we manage it? So when we look at VLab, which is the Volatility Laboratory, it's a website of the Volatility and Risk Institute that Dick Berner and I chair. And this website measures different kinds of climate risk and other kinds of risk and updates these every day because they're based on market prices. There is new information every day. It's only a little bit of an increment, but it changes, and it gives you a chance to see results about as fast as they're happening. And if you go to our chatbot and you ask about C risk or marginal C risk, which are the ways we measure banking risk, this is what the chat box says. C risk is a way of measuring, does the financial institutions have enough capital to withstand a climate risk? And if not, how much capital would it need? It's a capital adequacy measure. Marginal C risk is measuring what is the dollar exposure of this asset to the kind of climate risk we're talking about. So what do you see? Well, here's an example. Here is Citibank, and the top graph is the C risk, which tells you about capital adequacy of Citibank over time. This is 5 years, I think. And what you see primarily here is a big, you see several things. You see it rises in 21, 22, which is the pandemic, but it's even higher in 23 and 4, which is the inflation period in the US. And the banks actually in the US were struggling. We had several bank failures in that period because treasury bills, which were treated as a riskless asset, lost a lot of money. And depositors left these banks and they made them weaker. So you can see capital adequacy was really at its worst during the inflationary period, but that it really began during the pandemic. If you look down here at the bottom curve, which is the exposure, this is the marginal C risk, you can see the effect of the pandemic very clearly here, how the pandemic was really an example of decarbonization at an extreme rate. We stopped driving, we stopped flying, we Zoomed to all our meetings. This is an example of what's sometimes, cold turkey decarbonization. And so you can see Citi looked pretty exposed at this point. However, their exposure dropped way down low and was still pretty low during this high inflation period. And this illustrates the difference between capital adequacy and exposure. Citibank was weaker during this period, but it's weaker for reasons besides climate change. This is its measure of how weak it was due to climate change. It's not so much. Here we see this spike here, which is in both graphs, is what was affectionately called by our president Liberation Day, I believe. But that's the day that the tariffs, reciprocal tariffs, were announced and the world stock markets collapsed. It turns out that the fossil energy market collapsed even more than the broad markets, And I think that's reflected here. It says if you own some energy stocks or energy loans, all of a sudden they look pretty dangerous. And so you see this exposure rising here. Okay, if you do this for, say, 1,500 banks around the world, you can aggregate them up into countries. We do that because everything is measured in dollars here. Both the exposure and the capital requirements are dollar measures. So we can add up over countries. We can add up the whole world. So this is the world's exposure of all financial markets, all big financial markets, to climate risk. And the top one is capital adequacy. The bottom one is exposure. And if you look at the exposure, the only thing you really see is the pandemic, and it might be a little bit higher here. Liberation Day is still in this picture, but you don't see a trend. When you look at the capital adequacy, you see a trend. And that trend is primarily due to the fact that the Chinese banks are very large and undercapitalized by our measures. There is a risk in the Chinese banking system that we think is substantial, and that adds up to being this big number in the world economy. So, how do we estimate these betas? Well, we use the statistical methods, but they are allowed to change over time. If we just did a regression, the beta would be constant, so that the exposure would be constant. The fact that it's time varying is fundamental to making this measure work and give us something that changes over time. There are many ways to do that. The way we do it here is with what is called dynamic conditional beta. When you estimate a regression, you calculate the variance-covariance matrix once for the whole sample. That gives you a constant beta. If you do it each day, you can forecast the next day, and when you forecast the covariance matrix, that implicitly gives you a forecast of what the beta is one day ahead. And so using the methods that actually my Nobel Prize was for, with arch-garch models for the volatilities and correlation models from dynamic conditional correlation, you can forecast the whole covariance matrix one day at a time as each new observation comes in, and build your beta from that. So this is a place where machine learning could possibly do something even smarter. So I'll come back to that, how it might work. Let me give you a second example, and I'm going to be very quick about it because I'm going to run out of time if I'm not careful. A second paper is called Mirror, Mirror on the Wall, Who's the Greenest of Us All? The title is that the best part of the paper? I don't know. But in any case, what we do is the same thing for individual stocks that we just did for banks. We do the same thing for funds. Now we're talking about doing it for individual stocks. In this case, what we're going to do is that we're going to estimate each year, 1 year at a time, the same kind of regression. So we get a beta on these hedge portfolios and t-statistics. And the question is, are these betas positive or negative? How big are they? Which are the companies which are the most green and the most brown when you do this? So if you do look at, on average, over the last 20 years, the greenest companies are the ones on the left, the brownest companies are the ones on the right. This is maybe not exactly the list that you would have said from a priori analysis. It's not exactly the list that comes out of the European commissions, regulations, but it's pretty much the list that comes out of the market's response. And the question that really we want to ask in addition is, why does the market think these companies are greener and these companies are browner? And so if you take all these betas and you actually say, what's the probability that in this year this company will have a beta that's in the top percentile or the bottom percentile of this distribution? We have a way of looking in this panel. This is a panel logistic regression that looks at, on the left two columns, which are the greenest companies, and on the right two columns, which are the brownest companies, and what are their characteristics. So here we've got characteristics as the determinant of the betas. And there's a few things to look at before you glaze over. One is that when you estimate with sector fixed effects, you get a good bit higher R squared. In other words, the most important thing is what sector are these companies in? That's particularly true for the brown companies. The green companies, it's a little bit less important. When you look at the characteristics of green firms, you see high profit margins, low long-term debt and interest exposure, high intangible assets, and high R&D, low emissions. And how about ESG data? Well, it turns out the E-score even has the wrong sign. And the ESG data that we use in this model seems not to be very significant. So I think that there are reasons to be concerned about whether ESG data is actually measuring what we want in terms of what's brown and what's green. And this is a sort of a statistical approach to that question. In the bottom, you see, again, the E-score is insignificant or significantly wrong for the brown firms as well. High emissions make you brown, but the bad E-score doesn't do it. In order to understand those results, I want to think about the fact that all these transition risks are risks to the future of your company. If you're the CEO and you're considered to be a brown company by any of these transition risks, then it's likely that your company will not be as big or as important in 5 or 10 years as it is today. I call this termination risk. There's a risk that your company is going to disappear. It's not a fact, it's a risk. And how does that affect your behavior today? Well, here are some things that I think come out of thinking about this question. You should presumably reduce capital expenditure, especially on long-term projects, or projects that will likely be what we call stranded assets. So you would expect less investment. You would expect consolidation so that the remaining firms don't fight with each other so much as you're headed toward this extinction point. So you might expect to see one firm buying up its competitors. That doesn't expand the supply, it merely changes the ownership. Investors who think that there is a termination coming up are not going to be willing to pay very much for this stock. And so you'd expect to see low price-earnings ratios and price-to-book ratios. Firms who are trying to get investors to buy their shares are going to have to give liberal dividends and liberal buybacks. They're going to buy their own stocks back. And we see a lot of that. And finally, you might think firms that are facing termination risk might try to diversify. They might try to develop green subsidiaries. But this is likely to be frustrated by the fact that they're paying a high cost of capital and trying to develop a product that would have a low cost of capital in the future. So they're unlikely to do that. So do fossil energy companies face termination risk? I don't think I'd want to stand there forever, but termination risk is in the future. Here's what you see for the market cap as a function of the US economy. Over time, you can see for all these oil and gas sectors, it's been declining. If you look at the change in the number of drilling rigs from last October to this October, you can see it's gone down in the US as well as in Canada and internationally. If you look at the price-earnings ratios sorted by sector, you see that the energy has the lowest price-earnings ratio. This is just this week. If you look at the price-to-book ratios, you see that it's also the lowest price-to-book ratio. So these are all things that we expect for termination. The new Nobel Prize was announced, and three men, Moker, Aghion, and Howlett, were all awarded the 2025 Nobel Prize in Economics, and they study the relationship between innovation and growth. It's interesting from the point of view of what we're talking about. They find that Schumpeter's idea of creative destruction is actually a central and important mechanism for our growth. That firms that innovate take away business from existing firms. But they're more productive, they produce better products, and they hire more workers, so that you see an expansion of the labor force just as some companies are dying. And their view is that when this operation does not happen effectively, growth stops. And one way that it stops is if the incumbent companies are able to block the innovations of the new innovators. And so it's important, if we really think that renewable energy is the innovation in this case, that we don't let fossil energy block the renewable energy that's happening. So what's the role for AI in this case? Well, I'm looking at correlations between hedge portfolios and stocks. I have some colleagues who are interested in the fact that there is a lot more information that the stock market uses than just returns. They use what they call asset embedding. That is, they look at all the characteristics of a firm that investors might see, and the same thing for the hedge portfolio. And so they have a better idea of what the correlations ought to be between these two than actually just the realizations we see. By the same token, the betas that I estimated are implicitly functions of all the characteristics that I had in that table. But I didn't estimate it that way, but it could be all done in one step, where the betas are just functions of characteristics. And that's sort of what I think they have in mind here. Of course, we'd still have an overfitting problem, but there are lots of solutions. And perhaps this is a way AI can actually play a role in risk management and stress testing. I'm out of time, but I want to say just 2 or 3 things about global climate politics. And this is, of course, the American eagle, bald eagle, is our national bird, looking pretty ugly and ferocious at this point. And in terms of climate politics, it's quite clear that if one country decarbonizes but many others don't, they're paying the cost of decarbonization, but they're not going to get much benefit because the global emissions will just dwarf their benefit. And so each country has an incentive to not decarbonize, to be a free rider. And what the problem with this is, if each country thinks of its own self-interest, then we are in just the hope category. We're not doing any public policy to help out of this. However, the cooperative solution is a better solution because we avoid the damages due to climate change. So how do we get from this competitive solution to a cooperative solution? Well, that, of course, could be a big topic, and it has to do with a lot about international relations, collaboration, and meetings like this. Meetings like this bring people together to talk about these issues across countries, and hopefully when we go home, we'll all be more interested in actually how do we get some kind of action in our country. In China, this is what some of Tibet looks like. This is a solar farm which is bigger than Manhattan. It's enormous. It's producing an enormous amount of electricity, and it's expanding dramatically. In the developing world, solar panels are a solution to the electrification problem in many cases, and so cheap solar panels are going to actually be an important part of economic development. In the US, we're subsidizing LNG terminals. There are a bunch of them, I think, in the Gulf of either Mexico or America, depending on your point of view, are subsidizing these terminals. And I feel like this is, going in the wrong direction. We're backing the fossil energy rather than the innovative renewable energy, but we'll have to see. So, will we be able to stop climate change? This is a question not of physics, but a question of economics and politics. I sort of think, basically, I'm an optimist. I believe that ultimately renewable energy will be so desirable that it'll dominate the energy market. That's what I see in these pictures. And I think that the economic policies of the Trump administration will be damaging to the US and to the rest of the world, and will ultimately be reversed after the consequences are realized. The captains of industry will see that deregulation and lower corporate taxes are not sufficient for national prosperity, which is kind of what I think has gotten them to support a lot of the administration policies. And I can only hope that this will happen in time to repair international relations and reduce both climate and other geopolitical risks. And last week in the US, we saw major protests, and we'll see if that continues or what that means. So here are three of my grandsons wondering what kind of world will they inherit. They're worried about it. And I should say probably pessimistic about our ability and willingness to fix things. But if we can tell them that we have a solution, they'll be a lot happier. Thank you.
So thank you, Professor Engle, for the mind-expanding perspective on the intersection between finance and climate risk. Due to time, we'll take one question from the audience.
I don't know whose hand you saw.
The second, the third row.
Okay.
Yeah.
The woman with the blue jacket. Okay.
Hi, thank you, Professor. My name is Lakra. I'm a data scientist in the UK, coming from London, trying to get the AI in a proper shape. Thinking about ESG metrics, if those metrics are at least misleading, and we've all seen that in the last years, is there any chance the government, especially the EU, will take your results, your beta, your GARCH model, I have a econometrics background, so I understand the gauge and the arch. It was my youth reading your work. So any chance, if the government will see the real results, because ESG points are a lot, could help, because small firms are doing everything they can to get those ESG points, but they are still brown assets. So do you think that can help for a real image?
I don't. I think ESG scores can be improved. They could better reflect what we think of as the exposure to transition risk. That's my view as to what they should reflect.
Exactly.
And, you know,
with this,
many people think ESG is more than climate. And the S and the G part are really not climate related at all. So that's part of it. But even the E score itself, so much of it is self-reported. It is promises of what people are going to do rather than realizations of what they're going to do. And I think that's the reason the market doesn't really view ESG scores as telling it what would be a sensible investment. So your question really was, if we improve the ESG scores, would that improve market performance? And I think any source of information that gives investors tools to help them achieve what they want. Suppose you want to hedge climate risk. Well, it might be that there's information that would be useful, but I don't think that the way it's been compiled is useful.
Maybe of new metrics, like exactly what you said about the beta, and that beta computing beta based on all the features. I can imagine how that can be done. Like I said, this is my specialty. We can add the new metric specific for the client change.
I feel
Maybe
bad.
forgetting the ESG.
I feel
Thank
bad
you.
interrupting, but please feel free to reach out during the coffee and lunch break. But thank you for the great question.
We should talk later.
Thank you,
Thank you all.
Professor Engle. Thank you once again.